What's up everyone, and welcome to part 2 of the Space and Astrophysics Iceberg. I'd like to thank all of you for your feedback on the last video. You guys are so awesome. These tiers are somewhat more interesting than the last two, and the entries do get longer. It doesn't get existential just yet, but trust me it will. And with that, let's get started with tier 3. Sputnik was the first man-made satellite to orbit Earth, being launched by the Soviet Union in 1957. There's not too much to say about Sputnik since it was one of the spacecraft ever made. The craft was able to transmit radio signals, but not a whole lot besides that, as it was a relatively simple probe. Despite its simplicity, it provided scientists with a lot of important data about the Earth's atmosphere. Sputnik ultimately disintegrated in re-entry 3 months after launch, and this gets a 1 out of 10 since it was just a simple probe. Uranus' sideways refers to the unusual axial tilt of the planet Uranus. Whereas most planets have a slight axial tilt, Uranus' tilt of around 97 degrees makes it spin on its side. So instead of spinning like a top like the other planets, Uranus sort of rolls like a ball across space. This also means that for a quarter of its year, only one side of the planet receives sunlight. The cause for this odd tilt is hypothesized to have been a collision with another large celestial body early in the planet's formation. 1 out of 10 for this one. You've probably come across this before, but the simulation hypothesis is the idea that our universe and everything in it is the product of an artificial reality. This would mean that everything from the beginning of the universe to today exists in the computer or some other artificial space constructed by a higher being. This would not only imply the existence of a higher order of beings, but also that we and everything around us are just complex lines of code that can be turned on and off at any moment. There is of course no concrete evidence for this theory, but like a lot of future entries similar to this, we have no way of knowing anyway. The internet has popularized this theory a lot. Many people have noted that some recent events in history are too bizarre and that it's evidence that whoever is running the simulation is bored and orchestrates them on purpose to see what might happen. Overall, this gets a 4 out of 10 because even though we don't have evidence of it, it's not impossible and the thought of it is a bit frightening. Exoplanets are planets that exist in solar systems beyond our own. Many of these have been found throughout the galaxy, some of which are much larger than even Jupiter. Exoplanets are interesting because many of them orbit their star within something called the habitable zone. This is an area a certain distance around a star in which liquid water and thus life may be able to exist. By looking at planets in the habitable zone, we may be able to more easily find potential extraterrestrial life and perhaps also find a suitable replacement for Earth if humans are ever advanced enough to efficiently travel through space. This entry gets a 2 out of 10 because they're just cool, but the possibility that one could be like Earth makes you wonder if there's any kind of life on it. The speed of light is a physical constant equal to 299,792,458 meters per second. This is the limit at which anything can travel through space. It is used in Einstein's formula E=mc², denoted as c, to find the energy of the object in joules as related to its mass. It's important to note that the constant is only that exact value in a vacuum. This means that in any other medium such as water, glass, or anything besides the vacuum of space, light travels slower. The speed of light is even used to measure distances across space with the light year. The light year is a unit of length that describes the distance traveled by a wave particle of light. This puts into perspective the true scale of the universe, as even if light is the fastest you can travel, it would still take you many lifetimes to reach stars further away from us. This entry gets a 2 out of 10 because it's just a value, even though it is incomprehensibly large. The age of the universe is thought to be around 13.8 billion years. For reference, the solar system and Earth would only be about a third as old. This age has been estimated using things like cosmic background radiation and the expansion rate of the universe. One of the reasons we can't know the exact age of the universe is because light made at its origin hasn't traveled far enough for us to see it. In other words, the earliest sources of light may be so far away from us that we cannot detect them yet because their light hasn't reached us. There are many more complicated concepts going into this that I'm going to talk about later, but that's the gist for now. This gets a 3 out of 10 because the thought of there being parts of the universe we can't see because the speed of light isn't fast enough is just ridiculous. Like, now you're telling me that the fastest anything can go is not enough to tell us about the entire universe? Black holes are celestial phenomena caused by a very large mass, such as a supermassive star collapsing in on itself and creating a point in space where nothing can escape, even light. Black holes are so dense that their gravity distorts time and space around them, pulling in matter around and into it. Once the matter crosses the event horizon, it goes into a powerful gravitational field and is pulled into the singularity. The singularity is a point in space where the mass of the black hole is so large that light cannot escape it. When a black hole does this with matter, it shoots out a jet of radiation from both poles at light speed. Black holes are extremely hard to study, but refined technology like the James Webb Space Telescope has made it much easier to see what really happens near these anomalies. I'm going to give black holes a 7 out of 10 because black holes spooky and confusing. Chris Hadfield is a Canadian engineer, pilot, and astronaut who notably served as commander of the ISS on the missions he was on. He's gained a lot of popularity on social media as he frequently posted online about life in the space station. He retired after he returned from his last mission in 2013 and went on to publish several books, and all around just seems like a really cool guy with a lot of passion for space. So he gets a 0 out of 10. And if you want an idea of how chill he is, in 2013 he tweeted this photo revealing he had brought Easter eggs on board the ISS so that he and his crew could celebrate while still in space. Venus backwards refers to how the planet Venus rotates backwards. While most planets rotate west to east, Venus rotates east to west. This means that on Venus, the sun rises in the west and sets in the east. The reason why this is strange is because normally, planets and other celestial bodies around the sun keep the momentum they held as they formed around the sun. This is seen in all planets except Venus and Uranus, meaning that at some point, the momentum of Venus and Uranus' axial spin was disrupted so hard to the point of them spinning backwards. This is usually thought to be caused by a large impact on the planet as it was being formed, but for something to have knocked Venus upside down, basically, it must have been extremely large. So I give this a 2 out of 10. Michael Collins was an American astronaut who was the pilot of the Columbia Command Module that orbited the moon during the Apollo 11 mission. This meant that Collins was up there in space alone while Neil Armstrong and Buzz Aldrin walked on the moon. For more than 21 hours, Collins was completely alone, isolated from not only his crewmates but from the rest of the human race. As he passed the dark side of the moon, he actually lost communication with Earth for 40 minutes. Even though people have said that this was the loneliest a man had ever been, Collins has said that he had never felt that way because of how important his role was to the mission. But despite that, think about how you would feel if you were in his position, not being able to communicate with anyone you know in a metal box outside your own planet. I'm going to give Michael Collins a 0 out of 10 himself, but I'm going to give his situation and the period of time he was alone a 4 out of 10. The moon is drifting away refers to how the moon is slowly distancing itself from the Earth at a rate of about 1.5 inches per year. The reason why is because variations in the Earth's rotation mess with the momentum that keeps the moon in orbit. It's hypothesized that in 50 million years, if the moon and Earth are not destroyed by the dying sun, the moon and Earth will be in such an arrangement that the moon won't appear to move in the night sky. This is so long from now that the sun exploding is more of a concern, so it gets a 1 out of 10. Center of every galaxy refers to how there is probably a supermassive black hole in the center of every galaxy. There is definitely one in the center of our Milky Way named Sagittarius A. All stars in the galaxy orbit the central black hole, but because of orbital paths, it is unlikely that many of the stars in the galaxy will be destroyed by it. Concrete evidence for the same case only exists for a handful of galaxies, but astronomers hypothesize that the formation of a galaxy is in some way connected to the formation of a central black hole. Therefore, it's possible that they all have one, and because black hole's spooky, I'll give this one a 4 out of 10. Satellites orbit Earth refers to how there are 6,500 of them orbiting our planet, according to UNOSA. Nearly half of those are communication satellites, with many others serving the purpose of Earth observation, GPS services, and science and technology development. I think the reason why it's so far down in the iceberg is because we don't think about just how many are up there. Like, there's just thousands that we're not aware of, and for that, we'll give it a 2 out of 10. If you remember back to Tier 2 with the Space Shuttle program, I skipped over 2 of the orbiters that were used in the program. These were the Challenger and the Columbia. On January 28th of 1986, the Challenger was getting ready to launch on a mission when the entire orbiter, along with the crew of 7, were tragically lost in an explosion. The disaster was caused by the failure of something called an O-ring seal, 2 of which had been compromised due to abnormal temperatures. The disaster caused the program to be suspended for 2.5 years and forced engineers to redesign certain components of future spacecraft so a similar event would not happen again. The Columbia was the final space shuttle orbiter designed for flight, but on February 1st of 2003, tragically disintegrated upon re-entry into the atmosphere and killed all 7 crew on board. The disaster was caused by damage to the thermal protection tiles on the left wing of the orbiter. The tragedy led to another suspension of the program until 2005, after which older space shuttles were only used to travel to the ISS. After that, the space shuttle program was retired in 2011, replaced by collaborative flights to the ISS. Because of the tragedy of the topic, I'll give it a 4 out of 10, and hopefully another accident like those never occurs again. Apollo 13 was the third mission intended to land on the surface of the moon. It was launched in April of 1970 and proceeded to the moon until landing was cancelled because an oxygen tank blew up, damaging another oxygen tank, the power supply, and their water system. This forced the crew to rethink the entire mission. They began to conserve water and gather all of the remaining resources of oxygen they could, since at this point landing on the moon was a no-go. The crew instead successfully adjusted course and flew around the moon to return to Earth. On their way back, the electricity was shut off and the temperature in the cabin dropped to 38 degrees Fahrenheit or 3.3 degrees Celsius, to the effect that water droplets even condensed on the walls. Thankfully, the crew returned to Earth safely about 5 days after the tank exploded. It turned out that the oxygen tank and a few of its components had been overheated during a launch test, and when you mix pressurized oxygen and high heat, you get a bomb. Overall, I give this a 4 out of 10, because even though nobody was harmed, the stress of the situation must have been immense for not just the crew on board, but for ground control as well. Laika was one of the first animals in space sent aboard the Sputnik 2 craft in November of 1957. She was a stray dog from Moscow who was chosen to board the craft because scientists thought dogs like her would survive in extreme conditions. Because atmospheric re-entry technology had not been developed, Laika's mission was unfortunately a one-way trip. Sadly, Laika died within hours because of a spacecraft component failing to separate, and on April 14, 1958, Sputnik 2 carrying Laika's body re-entered the atmosphere and disintegrated. I'm going to go ahead and rank this a 3 out of 10 because Doggo died in space and that makes me sad. Tier 4 begins with the tyranny of the rocket equation. This entry refers to rocket fuel and the limit of how much you can carry on a rocket. Earth's gravity is such that you need a lot of energy to escape it, and a good way to do that was with burning a lot of rocket fuel. But the thing is, if you want to bring things into space with you so that you can live, you're going to need more fuel to push that mass. But that fuel also has mass, and so on. Basically, the more things you want to carry into space, the more and more fuel you exponentially need in order to get to space. It's referred to as tyranny because no matter how much fuel you want to add, you will need more fuel for it, a larger tank, more pipes, and so on. Overall, it gets a 1 out of 10. It's a bit concerning if you're an engineer, but not for everyone else. Historic supernovae refers to how throughout history, observers of the night sky have recorded supernovae. So far, there have been 8 proposed historically observed supernova events starting in the year 185 AD, with the most recent observation in 1604. However, only half of these are confirmed. Later on, with the development of telescopes and more advanced technology, modern astronomers have discovered many more supernovae and have even captured the explosion of one in 2008. Now, supernovae happen so far from us that we really should not be concerned about it, so I'm going to give this entry a 1 out of 10. TV static is caused by electromagnetic noise detection by analog video display or recordings. Most of this noise is caused by nearby signals from other electronics or ambient radio waves, but a small fraction of it is caused by something called cosmic microwave background radiation or CMBR. CMBR is supposedly leftover radiation from the Big Bang, as when that event took place, it would have radiated large amounts of energy, some of which we can detect today. But more on CMBR later. This is a 2 out of 10 entry because us being able to detect such energy today is kind of insane. Stellar classification is the way by which astronomers classify stars. It uses something called the Morgan-Keenan system, which designates a letter to a spectral type and plots that against a star's absolute magnitude in a kind of chart called a Hertzsprung-Russell diagram. The letters used to classify the spectral type are O, B, A, F, G, K, and M, and they describe a star's light color range, with O stars being blue, F stars being white, and M stars being more orange or red. Absolute magnitude is essentially a star's luminosity. Using these two values, astronomers can then lump stars together into different classes where they can be studied. Stellar classification gets a 1 out of 10. Cosmic rays are high-energy particles generated by stellar objects such as the Sun, but they can also come from outside the solar system. Most cosmic rays are atom nuclei, but some are something called a beta particle, which is a high-energy electron produced when a neutron decays into a proton, a neutrino, and said beta particle. Neither type of ray is harmful to humans under the Earth's atmosphere, because you don't receive a substantial dose of it per year to affect your health. In space, however, there is no atmosphere to protect humans, so long-term exposure to them in there antimatter, and in planets with light atmospheres such as Mars, could bring potential side effects. This gets a 2 out of 10 because even if Earth shields us, if that somehow goes away, we're toast. Micrometeorites are small space rocks less than a gram in mass that manage to make their way down to Earth. In early space exploration, these were thought to pose a bit of a problem, since you cannot avoid these hitting spacecraft. Even though they're small, some can travel faster than bullets, so enough of them can severely damage spacecraft. In 1946, Fred Whipple designed a sort of shield that vaporizes them on impact, and various forms of his invention have been used in spacecraft ever since then. I'm going to give this entry a 2 out of 10 because it's space shooting bullets at spacecraft. Far beyond the orbit of Neptune exists a region of the solar system called the Kuiper Belt. Much like the asteroid belt, this region is where large amounts of stellar objects gather, although these are smaller in size and composed of a lot more icy material. As we saw in the Pluto entry, there is a lot of material here left over from the solar system's formation, and it is home to dwarf planets like Pluto as well as comets and icy asteroids. All of these objects are lumped into a category called trans-Neptunian objects, of which there are potentially millions. We've studied several of them, but because their orbits are so eccentric and large, it would take so many missions that for now we've decided to focus on exploring other things. I'll give the Kuiper Belt a 4 out of 10 because it's so far removed from the rest of the solar system that we don't know a lot about it. Even further beyond the Kuiper Belt and Neptune is the Oort cloud, a region of interstellar space which contains many long-period comets, gases, and small amounts of meteorites, as well as various other kinds of icy debris. The innermost region of the Oort cloud is 1,000 times further away than the Kuiper Belt is to the Sun, really putting into perspective the vastness of our solar system. For example, Voyager 1, the furthest man-made object in space, won't reach the Oort cloud for another 300 years. And this gets a 5 out of 10 because it's even further and more unknown than the Kuiper Belt. Antimatter by definition is matter composed of particles which have the opposite charge of normal matter. You might know that matter is made of atoms, which themselves are made of protons, neutrons, and electrons. But there are also particles which are the opposites of these. For protons you have antiprotons, for electrons you have positrons, and for neutrons they are antineutrons. Antiprotons are the same mass as a proton, but with a negative charge. The same idea applies to a positron, which is the same mass as an electron, but with a positive charge. An antineutron is a little more complicated because neutrons don't have a charge, thus neither does an antineutron. Instead, an antineutron is made of antiquarks, which are particles too complicated to cover in this video. Antimatter usually results from some types of radioactive decay and can also be made by cosmic ray collisions. If a particle of antimatter collides with a particle of normal matter, they annihilate each other and release a lot of energy. Because of how they form naturally, antimatter particles are very rare, but physicists at the CERN facility in Europe are currently studying antimatter using the Large Hadron Collider. I'll give antimatter a 3 out of 10 because even though its interaction with matter is violent, it's still quite rare. Bird legs puffy face refers to how water in your body interacts with low gravity in space. Here on Earth, gravity pulls water in your body down towards the ground and your feet, but in space, what happens is that the excess water rushes up to your head instead. This causes an uncomfortable puffy face for astronauts, and the bird legs part refers to how that excess water leaves your legs. An effect like this can have some unwanted consequences on astronauts' bodies, affecting their cardiovascular system, their nervous system, and as we'll see later, their eyes especially. 3 out of 10 for this entry because of concerning health side effects. This corned beef sandwich entry makes me so happy. So back in 1965, before boarding the Gemini 3 mission, pilot John Young hid a corned beef sandwich in his spacesuit. And this is notable because astronauts aren't allowed to eat things like that in space because crumbs and other particles can get in people's eyes or electronics. And this is why they give them special foods in packs, but man's really wanted his sandwich, I guess. I like fun entries like this, but 0 out of 10. Fusion likely refers to nuclear fusion, which is the process that allows the sun to generate heat. How it works is that atomic nuclei merge to form heavier elements, releasing energy. As long as you have enough hydrogen atoms, this process can be self-sustaining in the case of the sun and other stars, which is why if humans are able to replicate this and keep it stable, it could mean renewable energy. The problem is, we have to basically do the equivalent of making a controlled star in a laboratory, so easier said than done. And if you ever seen Spider-Man 2 with Tobey Maguire, this is basically what Doc Ock's machine was. And overall this gets a 2 out of 10 because the consequences of making a lab star is concerning even though the possibility is slim. The Fermi paradox asks the question as to why we have no evidence of intelligent aliens despite the high likelihood that they exist. The paradox is named so because of a conversation physicist Enrico Fermi had with other physicists. The conversation had to do with UFOs, faster than light travel, and eventually intelligent extraterrestrials. The question is interesting because we have no convincing evidence that there are such forms of life, but space is so large and plenty of time has passed for advanced civilization to develop and reach us. I think I'll give this a 2 out of 10 since it has to do with intelligent aliens, but it's nothing too concerning. And that's going to conclude part 2 of the iceberg. I'm going to keep it at 2 tiers per part, so expect about 3 more after this one. I do have another type of video planned between this and the next part, but I will have part 3 out soon after. And stay tuned because the next couple tiers is when things really start heating up. Thank you all for watching, and I'll see you next time.